The first anomaly appears underneath the train, not above it. In photographs dated to the late 1800s, the undercarriage sits unusually low, tightly compacted, with clearances that leave almost no room for error. The suspension components appear enclosed, not exposed. The geometry suggests controlled vibration, not rough movement. This is not how early rail vehicles are supposed to look. And yet, the date on the photograph remains. The official explanation is simple and restrained. Railways developed quickly. Engineers experimented. Some designs were ahead of their time. Workshops adapted. Skilled labor existed. Given enough effort, complex machines could be built even in the 1800s. That explanation accounts for innovation. But it does not account for the environment these designs supposedly came from. What's missing here is the workshop itself. Train manufacturing in the 1800s relied on open floors, overhead cranes, and hand-operated tools. Assembly required clearance, space, access. Yet the vehicles in these images appear designed to be assembled in controlled conditions, with precise tolerances and repeatable alignment. Rivets are evenly spaced. Panels align cleanly. Components interlock in ways that suggest pre-planned assembly sequences. Doorways shown in surviving depots are narrow compared to the width of the rail cars. Floor load markings do not match the vehicle weights. Staircases leading to assembly platforms are steep and irregular, not suited for repeated transport of heavy components. These spaces were not designed for what appears inside them. Measurements deepen the problem. Axle housings appear machined to tight tolerances. Bearings are recessed. Wheel profiles are consistent across regions. This level of standardization implies tooling capable of repetition. But documentation shows workshops working largely by hand, with limited precision instruments. Why would a vehicle be designed with such compact internal geometry if it were meant to be built using variable manual methods? Once this detail is noticed in one photograph, it becomes harder to ignore elsewhere. Rail cars from different regions share similar undercarriage proportions. Suspension systems repeat. The relationship between wheel diameter and frame height remains consistent, even when external styling changes. These similarities appear across borders. Different builders, different decades, the same constraints. It suggests not a series of isolated experiments, but adherence to an underlying design logic. Maps from the period mark large rail workshops on city edges. The buildings exist. The dimensions are known. Many are long but not tall. Ceiling heights limit vertical assembly. Crane systems, where present, appear insufficient for lifting fully assembled frames. The vehicles seem too integrated to be assembled in sections. Photographs inside these workshops are rare. Those that exist focus on finished vehicles, not construction. Tools are visible but not specialized. Lathes are small. Milling machines are absent or rudimentary. There is no visual record of how certain components were produced. That absence becomes more noticeable around 1890. Before that, records are sparse but continuous. After that, they become selective. Drawings show external views, not internals. Blueprints omit dimensions that would clarify manufacturing steps. Notes reference standard components without defining them. Around 1905, the language changes. Reports begin referring to legacy stock and existing assemblies. The phrasing suggests inheritance rather than fabrication. But no transition is described. Then, around the early 1920s, something shifts again. Older rail cars are quietly withdrawn. Some are dismantled. Others vanish from inventories without explanation. Workshops that once produced rolling stock are repurposed or closed. The documentation does not describe a failure. It simply stops. What kind of event causes production knowledge to disappear without being replaced? There are no reports of accidents related to these designs. No widespread defects. No public concern. The vehicles simply leave service. Their replacements are simpler, heavier, less compact. Clearances increase. Designs become more forgiving. If progress is linear, this reversal is difficult to explain. Archives hold photographs of dismantling yards. Frames are cut apart. Components are separated. The process looks careful, selective. Certain parts are removed intact. Others are scrapped. No notes explain why. In some cases, the dismantled vehicles are stored rather than destroyed, covered, catalogued, then lost to time. Inventory numbers appear once, then never again. Workers' accounts exist, but they are indirect. Mentions of difficult maintenance, unusual alignment, sensitive balance. These phrases are vague. They do not describe failure. They describe something hard to replicate. If the designs were simply advanced, why not improve them further? Why retreat? The question lingers in the architecture. Old depots have service pits aligned precisely beneath tracks. The spacing matches the undercarriage geometry of the older vehicles, not the newer ones. Later trains do not fit as cleanly. The pits remain, unused or modified. These pits suggest routine access to enclosed systems. Systems that later designs abandoned. In several cities, identical pit layouts exist, despite being built independently. The measurements match. The depth matches. The access points align with axle assemblies no longer in use. Once again, repetition without explanation. The record gap widens in the 1930s. Technical journals stop referencing certain suspension types. Patents are not renewed. Drawings disappear from reprints. Later histories summarize the period in broad terms, skipping specifics. What's missing here is not information, but continuity. If these trains were impossible to build, they should not exist at all. But they do. If they were possible, the knowledge should persist. But it doesn't. Photographs show workers standing beside completed vehicles. They appear calm, unremarkable. No sign that the machines behind them were extraordinary. That contrast is unsettling. Either the machines were normal to them, or the image hides something not shown. The undercarriage remains the most persistent anomaly. Compact, integrated, quietly complex. It suggests an expectation of smooth operation beyond what rough track conditions